So for section 2.2, which is the product rule, product meaning multiplying, right? The key idea for the product rule here is if I have a function p of x that's equal to f of x multiplied by g of x, and f of x and g of x are both differentiable functions, meaning that I can get the derivatives of them, then in order to get the derivative of p of x, p prime of x is equal to, take the derivative of the first part, f of x, so f prime of x multiplied by, copy down the second part. Add that to get the derivative of the second part, g prime of x multiplied by, copy down the first part. So the way that is easy to think of it here is if I say that the product rule can only work if I'm multiplying two things. Like not if there's three, not if there's four, but it has to be the product of two things. They don't have to be binomials, right? They could be a trinomial, which we'll see an example of that. So the first thing to do is identify your two parts before you start. What's my part one and what's my part two, so that I know which part to get the derivative of and which part I'm copying down. And then I switch it. So for example here, I have the function p of x is equal to 5x plus 2 binomial multiplied by 8x minus 3 binomial. So this one is pretty easy. I can see my parts right here, right? This is part one. We're starting with an easy one, and this is part two. So let's follow the rules to get the derivative. P prime of x, get the derivative of the first part. So the derivative of 5x plus 2, there's a 1 there. So the 1 comes in front and gets multiplied by the 5. And then it's x to the power of 0, which is just 1, right? So it'd be 5 times 1. So I'm just going to narrow things down now, not write as much down. Copy out g of x, copy out the second part. So it's really just 5 multiplied by 8x minus 3 plus sign. There's always a plus sign. The derivative of the second part. So again, there's an exponent of 1 there. 1 times 8 is 8. X to the power of 0 minus 0. X to the power of 0 is 1, so that's just 8 multiplied by, copy out f of x, copy out the first part. 5x plus 2. And then I can go farther and I can distribute in and multiply everything here by 5 and multiply everything here by 8. So I would have 5 times 8 is 40x, 5 times negative 3 minus 15, plus 8 times 5, 40x, 8 times 2 plus 16, and then collect your like terms, right? So we've got a single x with an exponent of 1, single x with an exponent of 1, and then we have a number or constants. So if we add those together, 40x and 40x is 80x. Negative 15 plus 1 is 80x plus 1. So this is to introduce a new rule, the product rule. But also, if I was given a question like this, for example, yesterday, I could have used FOIL and expanded the question, right? And then simplified it. And then get the derivative once I had simplified and FOILed this. So I could have done this if it was yesterday. I'm just providing another rule for when the questions get a little bit more difficult, where using FOIL might not be as easy of an option. Then here's another option to get the derivative, would be to take the two parts and use the product rule. So let's continue on here. Differentiate for example 1. So differentiate just means find the derivative, right? So it's just saying get the derivative of whatever the question is. But I need my two parts. Remember, if I don't have two parts, I can't do the question. So I have h of x equaling x cubed plus 4x squared minus 3. So there's part 1. Again, it doesn't have to be a binomial, it can be a trinomial. multiplied by 2x squared plus 9. There's my part 2. So I have my 2 parts. I don't need anything to get started. I can just go ahead and follow the product rule. You're going to need some more room here. So h prime of x is equal to the derivative of the first part. So that would be 3x squared, right? Plus 8x, and then minus 0. So I'm just going to close my bracket. Copy out, multiplied by the second term, 2x squared plus 9. Your adding sign. Add to that the derivative of the second part. So 2 times 2 is 4x to the exponent of 1, right? Plus the constant plus 0. So just 4x multiplied by the copying out the first part. X cubed plus 4x squared minus 3. And then we have to simplify further, right? So let's use FOIL here. First, outside, inside, last. 3 times 2 would be 6. And when you multiply, you add the exponents. 2 and 2 is 6x to the power of 4. 3x squared multiplied by 9 is just 9, 18, 27 positive x squared. 8 times 2 is 16, but then I have x cubed. And then 8 times 9 is 72x, and that is all adding, just double check. 6x to the power of 4 plus 27x squared plus 16x cubed plus 72x. And then I'm going to add to that. If it was subtraction, I could put the bracket, but since I'm adding, I don't really have to put the bracket in. And then that's just a monomial multiplied by a trinomial, right? So just distributive property. So 4 times 1, that's in front here. 4x to the power of 4, 16x cubed minus 12x. Okay, now collect like terms. We might want to color code these here. So 6x to the power of 4. Here's another power of 4. There's cubed here. And make sure you add the sign in front that goes with it, and cubed here. This is the only squared. And then I have a single x to the exponent of 1 and a single x there. So if I were to put that together, I have 6x to the power of 4 underlined, 4x to the power of 4. So that's 10x. What, do I add 4 plus 4? When do I add 4 plus 4? When I'm multiplying. I'm not multiplying, I'm adding. So to collect like terms, it stays a power of 4, right? 10x to the power of 4. Next would be my exponent of 3. So 16 plus 16 is 32. X cubed. Next in order would be my exponent of 2, and that's by itself. So 27x squared. And then my 72 minus 12 would be positive 60x. And then I cannot go any further. Those are that's my derivative. That's my h prime of x of this original function. The other question here for B is going to be much longer. So I'm actually going to move this up a little bit. I don't know if that's going to help me. We'll see. And just kind of section this off. So that's all that we have for A. Okay. For B, let's use a different color. So for B, again, the first rule is that I need my 2 parts before I can do my product rule. Here I have 3. 1 part multiplied by the second part multiplied by the third part. So in order to have just 2 parts to use product rule, an easy way to get 2 parts would just be to multiply that x in here, right? So don't put y prime because we're not getting the derivative yet. We're just playing around with the original function. So y equals x cubed now, plus x is the numerator. So x times 2 would be 2x over x squared. And put brackets. So x cubed plus 2x over x squared multiplied by, we can copy out the second part, but we have to do something to it because The x squared, remember we don't want fractions when we're getting a derivative, and we don't want square roots. So we have to get rid of both of these things. So now we would have x cubed plus, well, first if I were to cancel out, that's x to the power of 1, right, divided by x to the power of 2. So if I subtract 1 minus 2, I would have -1, or the 1 on the bottom. So if I bring it up, it would be 2x to the exponent of -1. And the same thing as a square root is x to the power of 1/2 plus 4. So now I don't have any more radicals, and I don't have any more fractions. So these are my two parts. X cubed plus 2x to the exponent of -1 would be part 1. You don't have to write that down every time, but x to the exponent of 1/2 plus 4 is part 2. And now I can go ahead and do my product rule. So now I would write down, I think for room, I'm going to go way over here. It started out as y, so y prime, right? And I need to get the derivative of the first part of the function. So the 3 goes in front, 3x squared. That part is, let's say, easy by now. But okay, let's just follow the rules for the derivative here. I have -1 that goes in front multiplied by 2, so that's -2. And then I'm subtracting 1. So -1 subtract 1 would be -2 as the exponent now in brackets, copied out and multiplied by the second part. So x 1/2 plus 4 plus sign, right? Now I'm going to get the derivative of the second part. So the derivative of the second part is to put the half in front, 1/2 x, and then it's 1/2 take away 1. So just off to the side somewhere. 1/2 take away 1 would be 1/2 take away 2 halves to put the same denominator. 1 minus 2 would be -1/2. So to the exponent of -1/2, that's it. That's my derivative, because that would be plus 0, and multiplied by copying out the first part. X cubed plus 2x to the exponent -1. Now this is going to be somewhat long. This is just distributive property, multiplying this into here, but this I would have to use FOIL, right? Just moving my equal sign over. So I have 3 times 1 is 3x. You add the exponents when you're multiplying. So 2 plus 1/2. So 2 plus 1/2 would be 2.5, right? What's another way to write 2.5 would be 4 over 2 plus 1.5, which would be 5 over 2. So 3x to the exponent of 5 over 2, then 3x squared times 4, so 12x squared. That one's not too bad. Then here I've got -2 times 1, so -2, and with my x, it's going to be -2 adding 1/2. So that would be -1.5, which would be -3 over 2. Or you could take -4 over 2 plus 1. -4 plus 1 is -3 over 2. And then again, -2 times 4, -8x to the power of -2. And then multiply this 1/2 x to the -1/2 multiplied by x cubed. So I would have positive 1/2 times 1 is positive 1/2. But then my x, I would add the exponents. So -1/2 plus 3, right, would be 2.5. So again, 2.5 we already did over here is 5 over 2. And then 1/2 times 2 would be 2 over 2 would be plus 1, or just plus x. -1/2 plus -1. So -1.5. -1.5 is -3 over 2. So it's not necessarily difficult, it's just tedious, and I feel like you have to really slow down and double check everything that you're doing. So now let's collect like terms. Change my color. I have a 5 over 2 here. They have to be the same exponent. I have a 5 over 2 here. I have a -3/2 here. I have a negative 3/2 here. And then I have a positive 2 and a negative 2, just to double check. Yes, so those are separate. So then my answer would be 3 plus 1/2. 3 plus 1/2, I just add, right, for my like terms, but I keep the exponents the same, is 3.5. Or if I had 2 as a denominator here, I'd have to multiply by 2. So it'd be 6/2 plus 1, which would be 7/2 x to the exponent of 5/2. So I've taken care of that. Plus the 12x squared. So that's exponent of 2.5. That's an exponent of 2, right? You want to go in order. Then we have an exponent of negative 1.5 and then negative 2. So the negative 1.5 is larger. So negative 2 plus 1 would be negative 1, or just negative x, right, to the negative 3/2. And then our last one, minus 8x to the power of negative 2. Now, that's my answer. I can't further simplify. That's the derivative of that function. But because the original had a fraction and had the radical, we need to put this back into the original form. So I'm still at the derivative here, y prime, though once I write it out, I don't have to write it out again. So I have 7/2, but remember x to the exponent of 5/2 is the same thing as the square root of x to the power of 5, because remember the 2 is hidden there in the square root sign. Plus the 12x squared I can't do anything with. I don't want this negative exponent either. So again, this is negative 1x. So I would have negative 1x, and then I would want to get rid of a negative exponent and bring it down into the denominator to have a positive exponent. So it would be negative 1 over x to the power of 3/2, positive 3/2. And positive 3/2 is the same thing as the square root of x cubed, because the denominator of 2 is out in front. Minus 8 over, again, x to the negative 2 would become x squared to make it positive. So that is our final answer there. Okay, let's try 2 more questions. Determine the equation of the tangent, which means the same thing as determine the equation of the tangent line, right? It's just that we don't, it's assumed that you're talking about the line when we're talking about the tangent, but determine the equation of the tangent line for this expression when x is equal to negative 1. So basically, to get the equation of the tangent line, it's asking me to find the derivative of this function and then sub in x at negative 1. So if I wanted to do the product rule, because this lesson is on product rule, I need 2 parts. Where are my 2 parts? I only have 1 part here, but I mean, obviously, if it's squared, I can just say negative 2x cubed plus 6x plus 1 and multiply it by itself, negative 2x cubed plus 6x plus 1. So there's my part 1 and there's my part 2. And now just to make sure I have room, I can go ahead and do the product rule to get the derivative. So get the derivative of the first part, which would be 3 times negative 2, negative 6x squared. 1 times 6 would be plus 6x to the power of 0 plus 0. So plus 6 times 1, so just plus 6, right? And keep it in brackets and then multiply it by copying out the second term. Plus sign. I'm going to erase this. I always go too close. I don't leave enough space, well, because I'm always worried I'm going to run out of room. Then get the derivative of the second term, which is negative 6x squared. Again, 1 times 6 is 6x to the exponent of 0, 1 minus 1, which would just be 6 times 1 plus 0, so just like that. And copying out the first term, the first part. Now simplifying. So it's pretty long. Now if I were to look at these, because to simplify, I have, just change my color. I have negative 6x squared plus 6 multiplied by, look at negative 6x squared plus 6 multiplied by negative 2x cubed plus 6x plus 1. There's two of the exact same thing here. So just to kind of make it easier on myself, I can say that that's equal to 2 times negative 6x squared plus 6 negative 2x cubed plus 6x plus 1. This term multiplied by 2 out in front. So now if it's simplified, at any point you can sub in negative 1. You don't have to simplify necessarily as far as you can. So now I can evaluate for x equals negative 1. So f prime at negative 1 is going to be equal to 2 times negative 6, negative 1 squared plus 6, negative 2, negative 1 cubed plus 6 times negative 1 plus 1. Just make sure I do that properly, right? So BEDMAS squared first. Negative 1 squared is positive 1. Positive 1 times negative 6 is negative 6. Negative 6 plus 6 is 0. Negative 1 cubed is negative 1. Negative 1 times negative 2 is 2. So 2 minus 6 plus 1. And if I don't want to do all that in my head, I can start writing it out. So 2 times 0 is just 0 times negative 4 plus 1. But 0 times anything is, I'm still going to get 0, right? So when I'm plugging in, I have the derivative, and I'm plugging in the value of x equals negative 1. This is equal to the slope of my tangent line, right? That's not an equation. I need the equation of the tangent line. So to find the equation, so I'm just going to move up. I'm going to go down here. So to find the equation would be y equals mx plus b, right? The equation of the tangent line is a straight linear line. What information do I have? Okay, so I'm given the slope of the tangent line is 0. I'm given that x is negative 1. So here, slope of the tangent line is 0. X is equal to negative 1. In order to solve for y, I need to sub negative 1 into my original function. So in order to solve for y, I'm going to have f at negative 1 back up here, and I'm going to sub negative 1 into the original. So negative 2 times negative 1 cubed plus 6 times negative 1 plus 1, and do all of that and then square it. So again, negative 1 cubed is negative 1. Negative 1 times negative 2 is 2 minus 6 plus 1 squared, which is negative 4 plus 1. Put it in brackets, which is 9. So 9 is my value of y. So I have my m, my x, my y, and I'm going to solve for b. So let's go, just because I ran out of room, I will just go up here. So y equals mx plus b. Be careful, my y is 9. My slope of the tangent is 0 multiplied by x. X is, it told me, negative 1. And I'm solving for b. Well, 0 times negative 1 is just 0. So my b is 9. So therefore, the equation of the tangent line would be y equals m x plus b, which is just y equals 9, right? So y equals 9 is a horizontal line. We've gone over that many times now. So if that's a horizontal line, that means that the equation of the tangent line, if that's the equation of a tangent line and it's sitting on a horizontal line, that has to be happening at a turning point in the graph. So it's either happening at a maximum point or a minimum point, just so that we're better understanding what we're doing. So that is the equation of the tangent line. It should be looking like y equals mx plus b, right? But just because we had our slope of 0 is why it doesn't quite look like that. One more. This one I may run out of room. If I can zoom out a little bit here. Yeah, I can't. Okay, I'll just do my best. I might have to erase and keep going. Determine the point or points, because I don't know how many there are, on the curve y equals x squared minus 2 multiplied by 2x plus 1, at which the tangent line will have a slope of -2. So it's telling me that the slope of the tangent is -2, right? We need to find the derivative. So do I have my two parts to do the product rule? I do. There's no work that has to be done there. So I can go right ahead to finding the derivative. So that's to get the derivative of the first part. So that's 2x to the power of 1. And then that's a constant, so minus 0. Copy out the second part, 2x plus 1, right? Your plus sign, get the derivative of the second part, which is just 1 here, times 2 is 2. X to the power of 0 is now just 2 times 1, so just 2 plus 0, right? Copied out, multiplied by the first term copied out, x squared minus 2. Then we continue on here and we can do distributive property. So 4x squared plus 2x plus 1, right? Plus 2x squared minus 4. And I can collect like terms here. I have a squared and a squared. So then I end up with 6x squared plus 2x and then a minus 4. So I was told, and just to reiterate, the slope of the tangent line is equal to -2. Well, the slope of the tangent line is equal to -2. That's what my derivative is as well, right? So that's equal to my derivative. So what I'm going to do is set -2 in place of my y prime. So -2 is equal to 6x squared plus 2x minus 4. And then we might be thinking, well, what do I do from here, right? If I were to bring the -4 over and I have -2 plus 4, then I end up with 6x squared plus 2x. And where is that going to leave me? So I might be able to solve for x by factoring if I put 0 on this side and simply bringing that -2 over to be a +2. So I have 0 equals 6x squared plus 2x minus 2. So I need to factor. I need to try to factor this to get my x values, right? So the first step in factoring is always common factoring. I can pull out a 2, so I'd be left with 3x squared plus 1x minus 1. So now I'm looking at the product and sum, two numbers that multiply to a times c. Don't worry about the 2, right? So -1 times 3, that multiply to -3 and add to 1. And the only things that multiply to 3 is 1 times 3. Whatever I do with that positive and negative sign, I'm not going to get a 1. So that means this, in terms of complex factoring, is unfactorable. So then what's another way to factor? I still have to solve this question. I can use, remember what to do in grade 11 or even grade 10 if you weren't able to factor. The next thing that we learned was the quadratic formula. Did you remember the formula? So use quadratic formula, QF, let's say for short. So for the quadratic formula, I'm only looking at, again, the part that's inside the bracket here. So my A value would be 3, my B value is 1, and my C value is, be careful, -1. And what is the quadratic formula? Try to remember. Let's go way up here. X is equal to -b plus or minus, is it coming back to you? B squared minus 4ac all over 2a, and then let's fill that in. So -1 plus or minus b squared is 1 squared minus 4 times 3 times -1, square root over everything, all over, I like to just do 2 times a right away, so 2 times 3 and divided by 6. So let's condense what's underneath the square root sign. So 1 squared is 1, -4 times 3 is -12, -12 times -1 is +12. So I have 1 plus 12. So the square root of 13 over 6. And you can show that much steps when you're doing that for me as well. Now this splits up into 2, right? We need the -1 plus the square root of 13, and then we need the -1 minus the square root of 13 divided by 6. So we can state that as the first part here, one of the x values would be -1 minus the square root of 13 divided by 6. And the second x value would be -1 plus the square root of 13 divided by 6. I don't know why I did minus first, but anyways, it doesn't really matter, right? Usually I would have done plus first, but -1 minus, -1 plus. And if you plug those into your calculator, the -1 plus square root of 13 over 6, because that is what I did first before, is roughly, so put that dot on top, 0.43. And the -1 minus square root of 13 over 6 is, again, estimated roughly -0.77. So those are my x values. But it's asking me what my points are. So I will have more than one point. So I need to find out what the y value is. So in order to find out what the y value is, I need to take these x values here and sub them into my original equation to solve for y. So I hopefully will have room here. So let's, again, our equation was y equals x squared minus 2, 2x plus 1. And I'm going to have, let's call it y1 in relation to x1. So not prime, subscript is equal to, when I see x, I put in -0.77 squared minus 2. That would be in brackets, right? Multiplied by 2 times -0.77 plus 1. So square that first, I'd get a positive, subtract 2, get an answer, multiply this, you'll get a negative, and then add 1, and then multiply those two beside each other, and you should have, which one am I doing here? The -7 point, you should get roughly, so put a dot on top, 0.76. And then same thing. Yeah, this is not, don't know if I'm gonna have room. We will try, sorry if it gets a little squished. And then y2, the second point is I go back to my original x squared, but instead of x, I'm putting 0.43. So I have 0.43, that's gonna be squared minus 2, all in brackets, and then multiplied by 2 times 0.43 first, and then add 1, and then multiply those two answers by each other. And when I type in 0.43 for x, I end up with a negative, roughly, put the dot on top, 3.38. So this point, the x value was 0.43. The y value is negative 3.38. Here the x value is negative 0.77. And the y value of my coordinate point is 0.76. And I should be putting a therefore statement somewhere. Like obviously in a test, there's still a little bit of room underneath here. So this is not where you should put it, but therefore the points are, this means like roughly estimating, cutting off the decimal, 0.43 and negative 3.38 is 1 point, and negative 0.77 and 0.76.